Hi students, today we are going to discuss about scheduling algorithms. Scheduling algorithms, we use scheduling algorithms for scheduling our processes in between our system. Okay, you know about the states like ready states, new states, and running state, terminated state, waiting state. Scheduling algorithm mainly schedule the processes to run between these stages. Okay, first of all, there are four types of CPU scheduling algorithm. One is fast come fast serve, and two is shortest job fast, and third is priority algorithm. Then fourth is round robin. Let's discuss about fast come fast serve. Then we will go through all these algorithms. In fast come fast serve, as you are noticing, fast come means the processes came fast will be executed fast. The process which came last will be executed last. It means the processes follow a queue. The first in queue will be executed first, and the last in the queue will be executed in last. Let's move towards example. Here is example given. It's example 1. Here is some serial numbers. You can also consider serial number as arrival time. Okay. First of all, you have to consider some terminologies. I am writing here terminologies. One is AT, arrival time, and another one is CT, completion time. One is arrival time, one is completion time. Arrival time means when the process came to the ready state, in the time point at which the process came to the or enter to the ready state, and completion time at the point which the process leave the system or terminated. Then also more terminologies like waiting time, then turnaround time, then our execution time. Okay. Execution time means the process takes time to execute in the system, and the time is called execution time. And turnaround time means the total time a process will be present inside the system. It may be waiting or it may be executing. It depends on the system. Then one is waiting time, which means maybe the process is waiting for entering the CPU or accessing the CPU. Next, consider here the serial number as arrival time. Okay, arrival time and completion times both are some time points at which I am going some time points means here I am saying that the train will be coming 6:30 p.m. It is a time point. Okay, I am saying that train will come nearly in between 1 hour. Then it's a time segment. Okay, arrival time and completion time both are time points. Okay, let's consider this as arrival time. Consider this as arrival time. Okay, in one, let's consider it AM. Okay, consider this as AM. 1 AM P0 enter the ready state. Then at 2 PM P1 enter the ready state, and 3 PM P2, and 4 AM P3. Okay, then the system which come fast will be executed fast. The process which come fast will be executed fast. P0 enter the system fast or enter the ready state fast, it will be executed. Let's move. But in Gantt chart, there is Gantt chart. you have to draw the Gantt chart. It's must. You have to draw the Gantt chart in exam, also semester exams. It is very important and very easy to define and easy to derive the answers from Gantt chart. Okay, let's discuss P0. Let's P0 came at 0. Let's P0 came at 0 second. Okay, let's think this is a Q. This is a Q. Okay, first came and second came, then third came, fourth came. Let's P0 came at 0, means 0 is the arrival time. Okay, and P0 executed, here is execution time or burst time, means how many time or the time taken by a process for execution. Takes 10 units, then 0 to 10, and P0's completion time is 10. After 10 the CPU will be free, then P1 will enter and P1 will executed. P1 will be executed for 4 seconds, then 10 to 14 P1 also terminated. Then after that P2 entered and P2 will be work for 8, 14 plus 8, 22 seconds, then P2 also terminated. Then P3 enter the system at 22, enter the execution state. Then after 6 seconds it will also terminate. 22 plus 6, 28, at 28 seconds the P3 also terminated. This is our Gantt chart. Okay, let's discuss about the completion time. Okay, this is our burst time. I am drawing a new row here, new column. It's completion time. Okay, it's completion time. P0 completed at 10, then P1 completed at 14. Okay, then P2 completed 22 and P3 completed 28. This is completion time. Then making another column which is turn around time. Okay, turn around time simple says how many time a process are inside the system, means it is in ready state or executing or waiting. All this system either in waiting, either in ready state or in terminated state or executed. Okay, turn around time means how many time a process inside the system. Okay, then completed in 10 seconds and arrival at 0 second, arrival at 0 and completed at 10. Now how many time it is inside the CPU? Completion time minus arrival time is turn around time. Okay, completion time minus arrival time is equal to turn around time. Okay, now example. As example, if you are saying that you came to the school at 10 a.m. and you are leaving the school at 4 p.m. Then you also studied some time, then also your recess and also some breaks and also some breakfast breaks. These are all included in your whole time. Okay, this is also called your turnaround time. You can also say this is your turnaround time. As there is a process, you can also say the turnaround time of you personal is 6 hours. Okay, like that. I can say here what is the turnaround time of process P0. Then the completion time minus arrival time. Completion time is equal to 10. At that time arrival time is equal to 0. Here you are seeing the Gantt chart. Gantt chart should be must. You have to draw the Gantt chart because it is easy. Because if I erase the table, you can find all the details inside Gantt chart. Okay, then the turnaround time will be 10 minus 1 is equal to 10 minus 1 is equal to 0. 10 minus 0 is equal to 10. The process P0 remain inside the CPU for 10 seconds or 10 units. Okay, and the execution time also 10 seconds. Then how much time he is waiting? He's never waiting. Okay, if you are coming to school and your all the classes totally 6 hours, and you are also in school for 6 hours, then how many time is there is for free, or there is for okay, how many time there is for your recess? In 0. That's like you can also find the waiting time. You can also find the waiting time by simple subtracting the burst time or execution time from turnaround time. Okay, here I am creating a new column, that is waiting time, which is turnaround time minus burst time. Turnaround time is equal to 10 and burst time is equal to 10. 10 minus 10, waiting time equal 0. So P0 waited 0 second or 0 unit to enter the CPU. After that, let's move towards P1. Process P1 entered in 10 seconds to the CPU. Okay, then leave the CPU at 14. Then 10 minus 14. Okay, here separate table for arrival time, but let me make a new arrival time. Let's consider our arrival time is equal to 0, then 1, then 2, then 3. Okay, it's easy. Okay, then process P1 enter to the system at 1 second. Completed in 14 seconds. Then he remain in the system for 13 seconds. How? 14 minus 1 is equal to 13. Okay, that's like the process P2 enter the system at 2 seconds and leave the system at 22. Then how many seconds? It remain 20 seconds or not? Remain for 20 seconds. Okay, then our P3 arrived at 3 seconds and leave at 28, and then he must be in 25 seconds. Okay or not? Then we have to calculate the waiting time. Okay, we have done with our work with our Gantt chart. If now we have to just notice the table. Okay, let's watch. If the system if the process took 13 seconds inside the system and executed for 4 seconds. Okay, we have completed our P0. Let's look at P1. P1 enter the system at 1 and leave the system at 13. Then how many second? P1 enter the system at 1 and leave the system at 14. Then the turnaround time is 13. Okay, after turnaround time he executed for 4 seconds. Total spent 13 seconds and executed for 4 seconds only. Then other time he is waiting. Other time is equal to 13 minus 4 is equal to 9. Then just like P2 process 2 enter the system at 3 seconds and leave the system 22. Okay, P2 enter the system as 2 seconds and enter the leave the system at 22 seconds. Then remain 20 seconds inside the system, and in 20 seconds he only executes for 8 seconds. Another time he is waiting. Okay, then from 20 seconds, if 8 seconds is executing and another 12 seconds is waiting, just like. Then our P3 came in 3 seconds and leave the system at 28 seconds. I remain inside the system for 25 seconds. Okay. Then in between 25 seconds, he only executed for 6 seconds. Okay. From 25 seconds, the P3 process only executed for 6 seconds. Then another all the seconds is waiting. Then 19 seconds he is waiting. Okay, you can make this also average waiting time. Average waiting time, and you can also find average turnaround time. Okay. Next, move to our next algorithm, which is shortest job first. Okay, here we have our example. Let's move some another example. Here is properly arrival time given. Here properly arrival time given. Now we have to make 2 new rows. Here is our completion time or waiting time. Yeah. Here is execution time. Here is completion time, and here is turnaround time. Okay. Okay, this is the serial number. When they came. Okay. Then P0 came in 0 second, and P1 came in 4 second, and P2 came in 6 second, and P3 came in 2 second. Okay. In FCFS, the process came fast, will be executed fast. P0 came fast. Okay, will be executed fast definitely. Okay, let me erase this. P0 arrived as 0, and the burst time are 5 seconds. P0 arrived at 0 and executed for 5 seconds. Then leave at 5 seconds. Okay. Till 5 seconds our CPU will be busy. Okay. And the another processes will be wait inside the ready state. Okay. Then P1 came in 4 seconds, P2 came in 6 seconds, and P3 came in 2 seconds. Okay. And definitely P3 came after P0. So P3 go for execution. Okay, P3 go for execution, and P3 execution time is 2. It will execute for 2 seconds, 5 seconds to 2 seconds, which is 7 seconds. Then after that P3 is terminated. Then the CPU is also idle. CPU is now again idle. Then after P3, P1 and P2. P1 came at 4 seconds and P2 came at 6 seconds. Definitely P1 will be go inside the CPU first. And then P1 execution time is equal to 3 seconds. Then P1 will be executed for 3 seconds and leave the CPU at 10 seconds. Then at last P2 executed for 7 seconds and enter the system at 10. Leave the system at 17 seconds. Okay, this is the Gantt chart. You have to draw the Gantt chart. It should be must. You have to draw Gantt chart. Then from Gantt chart we will find our completion time. Here is our completion time. P0 completed at let it erase. Okay, let me erase. Looking clean. P0 enters at 0 and executed for 5 seconds and leave the system for 5 seconds. leave the system at 5 seconds. The completion time is equal to 5. Then P3 leave the system at 7. P3 completion time equal to 7. Then P1 leave the system at 10. P1 leave the system at 10. P1 leave the system at 10. Then P2 leave the system at 17. Okay, 17. Okay, we have our completion time and arrival time. We have to first find the turnaround time, and a turnaround time means the total time a process inside the CPU. Total time a process is inside the CPU. How can you find the turnaround time? We have to just simply subtract completion time minus arrival time. Then completion time is equal to 5, arrival time is equal to 0 for P0. Then 5 minus 0 is equal to 5. Okay. Then 10 minus 4 for P1. 10 minus 4 is equal to 6. Then turnaround time for P2. 17 minus 6. 17 minus 6 is equal to 11. Okay. Then turnaround time for P3 is equal to 7 minus 2 is equal to 5. 7 minus 2 is equal to 5. Okay, we have our turnaround time and we have burst time. We can easily find our waiting time. Okay, so we have to find the waiting time. Turnaround time minus burst time. Turnaround time 5 minus burst time. Turnaround time 5, burst time 5. 5 minus 5 0. Then turnaround time for P1. Turnaround time 6 and burst time 3. 6 minus 3 is equal to 3. P1 waited for 3 seconds. Then for P2 the turnaround time 11 and the execution or burst time 7. 11 minus 7 it's 4. Then P2 waited for 4 seconds. Then P3 arrival time 2 and our completion time 7 and 5 our turnaround time. Then from turnaround time we have to find the waiting time. Then turnaround time minus burst time. Turnaround time 5 minus burst time 2. It is 5 minus 2 it is 3. And you can find average waiting time. Okay, and here you can also find average turnaround time. Okay, it's easy. Okay, we have discussed some numericals. I think I have cleared about FCFS. Okay, here is the answers. You have to check again if you have not understand. Then here is turnaround time given again, turnaround time, waiting time, all this. Let's move to our shortest job first. SJF full form means shortest job first. Okay, here is some theory you have to write them. Then we have two types of shortest job first. First of all, you have to understand what is non-preemptive and what is preemptive. Okay, what is non-preemptive and what is preemptive. If I am saying non-preemptive, then it means very simple. What is the non-preemptive says? If a process is inside the CPU, it will leave the CPU willingly only. If the process want to leave the CPU, then it may leave. It will leave. Okay, if the process completed its execution, then it's definitely leave the CPU. Okay, but in preemptive, if a process is inside the CPU, it may or may have leave the CPU. It may leave the CPU willingly or may have to leave the CPU forcibly. Okay, this is non-preemptive. Very simple. Only leave the CPU if it's completed or willingly. Okay, willingly. It can be forced out. Okay, in preemptive it can be, the process can be forced out. Okay, these are the simple concept. These are some theory parts. If you want to note this, then I have some examples. Okay, SJF means shortest job first. Shortest job means the processes which have less execution time will be executed fast. will be executed first. You have just relate with an example. In your village shops, if someone is taking a very huge number of goods, or any person taking a small amount of goods, the person taking small amount of goods will definitely say, भाई थोड़ा छोड़ दो, मेरे को एक ही सामान लेने दो, फिर आप ले लेना. ऐसा होता है ना, वही वाला चीज़ है. Shortest job first means the process having less execution time will be executed first. And then we have to discuss about shortest job first. Okay, here's arrival time given. In previous numerical, the arrival time is not given. I have not noticed about arrival time. Okay, this is this is preemptive. Let's move to our non-preemptive. This is non-preemptive. Arrival time not given. Let's consider as 0, 1, 2, 3. This is arrival time and consider it as 0, 1, 2 and 3. Okay, consider it as 0, 1, 2, 3. Okay, then is a process, and I am drawing 3 columns. Okay, this is waiting time, completion time, then turnaround time. Waiting time, completion time and turnaround time. Okay, shortest job first thing, the process which have less execution time will be executed fast. Let's assume first let's erase the arrival time. Let's assume all these are came at a time at 0. All these are came at a time at 0. Okay, all the processes are present at 0 second. Okay, the processes have less time will be executed fast. Okay, which is execution time less? The 4 is the smallest execution time. Okay, which is P1. So P1 will be executed first. Then from 0 to 4 seconds, the P1 will be executed. Then P1 terminated. Okay, and then this is P1 is executed. P1 is executed. Then 10, 8 and 6. From 10, 8 and 6. 6 is smaller. Then P3 will be executed for 6 seconds. From 4 to 6. From 4 to 6. 4 to 6, 10. Okay, for 4 to 6, 10 seconds. Then P2 also executed. Sorry. P3 executed. Then from 8 and 10. From 8 and 10. From 8 and 10. 8 is smaller. So P2 executed. And P2 burst time 8 seconds. So 10 plus 8, 18. Then P2 also terminated. Then in last P0 executed for 10 seconds. From 18 to 10, 28. Okay, this is the simple funda. Okay, let's write our this is our waiting time, this is arrival time, which is 0, 0, 0, 0. Okay, then from Gantt chart we will find our completion time. P1 completed in 4. P1 completed in 4. Then P3 completed in 10. P3 completed in 10. Then P2 completed in 18. P2 completed in 18. Okay, then P0 completed in 28. Okay, then we can find our turnaround time. How? With completion time minus arrival time. 28 minus 0, 28 turnaround time 28. Then 4 minus 0, 4, then 18 minus 0, 18, then 10 minus 0, 10. Okay, it's easier to find turnaround time. Then you can find waiting time. How can find waiting time? Turnaround time minus completion time. Turnaround time minus execution time or burst time. Turnaround time minus burst time, you will find our waiting time. Then turnaround time is 28 and execution time is 10. 28 minus 10, waiting time 18. Then P0 is waited for 18 seconds. For P1, turnaround time 4, and execution time 4. 4 minus 4, 0. देखो, execution time 4 and turnaround time 4. 4 minus 4, 0. And P1 never waited. Okay, P1 came and entered the system. And then P2 have turnaround time 18 and executed for 8 seconds. Then P2 waited for 10 seconds. Then P3 turnaround time is equal to 10 and execution time is equal to 6. Executed for 6 seconds and another 4 seconds he waited. This P3 waited for 4 seconds. Then you can find average waiting time and average turnaround time. It's easy. It's a bit easier to find. Okay. Then here is an important part of preemptive shortest job first. This is very much important. Preemptive shortest job first. This algorithm is also known as SRTF, shortest remaining time first. Okay, preemptive SJF algorithm is called shortest remaining time first. Okay, let's move. Here is separate arrival time. Okay, I am making 3 rows here. One is for waiting time, another one for completion time, and another is one for turnaround time. Okay, waiting time and that is for turnaround time. Okay, then first of all at 0 second. Okay, this is preemptive. The process can be forcibly or forced out. A process can be forced out. Okay, in 0 second P0 is present. In 0 second P0 is present and other processes are not present. Okay, in 0 second P0 arrived at 0 second, only P0 is present at 0 second. So P0 will be enter the CPU first. CPU never keep idle. So P0 will be, it's P0. Okay, P0 will be entered the system first. Okay, and this is the execution time. What is 8? After just 1 second, after 1 second, he executed for 1 second. Then the remaining execution time is 7 seconds. Okay, then after 1 second, what happened? P1 came and P1 have a execution time 4. So P1 participated. Okay, then P1 participated for again 1 second. Then in 2 seconds P2 came. But P2 have our execution time is 9. Then after 1 second P3 came, which has execution time much. Okay, you have to just be conscious here. this Gantt chart is wrong. Okay, I am describing how this is working. Okay, first P0 enter the system for 1 second and executed for 1 second and goes outside, because P1 enter the system and P1 has the less execution time. Then after 1 second P2 came, but after 1 second the P1 is executed for 1 second, so it is 3 second remaining. Okay, while P2 came then while P3 came, it also executed for another 1 second, so 2 second remaining, and that time the 2 second is less than all this execution time. So P1 is executed for whole 4 second, for whole 4 second. 1 plus 4 is equal to 5. Then P1 will be terminated. Okay, P1 terminated. After that we have all our data. After 5 second we have all our data. How? After 5 second all the processes came in 0, 1, 2, 3. Okay, so our P1 is executed. Okay, I have 3 processes, P0, P2, P3. Okay or not? And we have their execution time. Let me just we have P0 execution time 7 and P2 execution time 9 and P3 execution time 5. So P3 will be enter the system. Then after P1 the P3 will be enter the system. P3 enter the system for how many seconds? No, 5 seconds. 5 plus 5, 10, and P3 will be terminated. Then P3 terminated. Then we have two processes, P2 and P0. P0 have execution time 7 and P2 have execution time 9. So P0 definitely go inside the CPU and executed for another 7 seconds. So it is P0. And P0 terminated. Then our P2 go inside the system and executed for 9 seconds. Okay, this is our system. Here you have to notice that P0 first enter the system. Okay, then forcibly out. Okay, it forcibly forced out from the system, and another process P1 goes inside the CPU. Okay, this is preemptive. Here is some here written wrong, but here is right. Okay, you have calculate the turnaround time, completion time, arrival time. Okay, let's calculate. First of all, erase this. Then calculate P0. P0 leave the system at 17, completion time 17. Okay, then P1 leave the system at 5. Then P3 at 10. Then P0 at 17. Then P2 at 26. Okay, and we have our turnaround time. We can find our execution time. We have a completion time. Then we can find our turnaround time. Then completion time 17 for P0. Completion time 17 and arrival time 0. Then total turnaround time 17 seconds inside the system. Then for P1 completion time 5 and arrival time 1 must be 4 second. Turnaround time minus 5 minus 1. Then for P2 our completion time is 26, and while arrival time is 2, then turnaround time is equal to 24, definitely much larger. Then for P3 our completion time is equal to 10 and arrival time is equal to 3, then 7. Okay, then you have to find the waiting time. How can you find the waiting time? Turnaround time minus completion time, which is 17. Turnaround time minus execution time. 17 minus 8 is equal to 9. Then turnaround time minus execution time. 4 minus 4 for P1 is equal to 0. Then for P2, turnaround time minus execution time. 24 minus 9, which is 15. Then for P3, turnaround time 7 and execution time 5. Then P0 waited for 9 seconds, and P1 waited for 0, and P2 waited for 15, and P3 waited for 2. Okay, this is SJF algorithm, and this is SJF algorithm, both preemptive and non-preemptive. Okay, these are the numerical values you have to calculate while you are